We're going to start the webinar now. I've got an agenda. We'll just flow through it quite organically. So what is this webinar about? We hosted Zindi in partnership with Lacuna, in partnership with Masakhane, an NLP organization in Africa, hosted a competition on Zindi to classify parts of speech, specifically in the Luo and Setswana language, which are quite interesting because they're from two different language groups. And they were not in the training set, which is quite interesting, but David will be going through that in a bit more depth. We have the winners here with us today, as well as the data set creator and as well as the funder for the data set creation and the competition. So we've really got the start to end of this pipeline with us today. I'm going to introduce Jennifer Pratt-Miles is a partner with the Meridian Institute and director of the Lacuna Fund. The Lacuna Fund sponsored the creation of this data set and also the opportunity to turn this into a competition where multiple people got to engage with the data. Over to you, Jennifer.
Thanks so much, Amy. And I am just going to share a couple of slides. These.
Cool, we can see your screen.
Great. Okay. And I want to make sure you're seeing just the slides.
Correct.
Okay, great. So as Amy said, I am with Meridian Institute, which is a not-for-profit organization. Our mission is to help people solve complex problems, make informed decisions, and implement solutions that improve lives, the economy, and the environment. And Meridian currently serves as the host for Lacuna Fund, which I'll be telling you a little bit more about today. Why was Lacuna Fund formed a few years ago? Because as you all know really well, AI applications and machine learning require training and evaluation data, but in many cases that data does not exist, especially for low resource languages. And even when data does exist, it's often outdated, missing key information, or not representative of local populations, contexts, languages. And as you all are probably well aware, this reduces accuracy and can lead to bias. I want to just let everyone know that Lacuna Fund is made possible by the generous support from these donors. And we're really grateful to all of them. And Lacuna Fund was formed to provide resources to data scientists in low and middle income contexts to help fill some of those gaps in the ML data sets that are needed to solve urgent problems in your communities. And lastly, I'll just show we're really excited. We recently completed an evaluation of Lacuna Fund this year, and that's available online now. We can put a link in the chat, but we're really excited to be able to share that we have been able to support grants in 54 countries to do data collection and data set creation and expansion around the world. And with that, I'll hand it back to you, Amy.
Amazing. Thank you so much, Jennifer. I received your Lacuna report from this year's work, and it's amazing what Lacuna and Meridian are doing. And I'm privileged to keep an eye on the data sets coming out, and just wow, you really are meeting your goals. Next, I'd like to introduce David Adelani. David is an academic research fellow at DeepMind. David helped create this part of speech data set and design the challenge. David, do you want to tell us a bit about Masakhane and then introduce the challenge? Over to you, David.
Oh, thank you very much for introducing me. And a big thank you to Lacuna for funding both the data set creation and also the Zindi competition. So I will introduce Masakhane very briefly. So the title is The Unreasonable Effectiveness of Participatory Research, because our goal is to take ownership of the problem of low resource languages and lack of data sets and try to address it ourselves. So there's a lot of initiative and a lot of people working to address this, starting from 2013. And Masakhane was founded in 2019. I was not part of the founding members. I joined in 2020 after the Africa NLP workshop. But who are Masakhane? So Masakhane is a grassroots research organization whose mission is to strengthen and spur NLP research in African languages for Africans and by Africans. And our goal is for Africans to shape and hone these technological advances towards human dignity, well-being, and equity through inclusive community building, open participatory research, and multidisciplinarity. So I think this is the state of Africa NLP in 2019. We don't really have content creators that much for Africa NLP, or even if they are available, it's not really open source. We don't really have many annotators working on these languages. And also just less people are building technologies through this. And the idea is that we try to address this so that we can have like a couple of projects. Many of these projects have been funded by Lacuna to create resources for these different languages, and also to do something useful using AI for our communities. So our work has been quite impactful in the last few years. We have been involved in a lot of data gathering, collecting data in a different way that involves the community that uses this. It's a little bit different from the way the Global North create research, because most of the people that are using this data are not involved in the process. We try to carry people and the speakers of this language along. Also, we have what's called the participatory research that like young people, university students are involved in both the data set creation and also building models for these languages. And also we're involved in building multilingual African models, multilingual cultural language models. And some of these models have been used for winning this kind of this competition that I'm going to talk about in 1 minute. And also a lot of things about hyperparameter tuning and building better models for African languages. So this is just to give you an idea of what Masakhane is about. Most of our communication happens on Slack, where we have over 2,000 members. And they self-organize into different groups to work on projects. And every year we organize African NLP workshop. There will be another one, since 2020, the first one happened online. And the second one happened online. This year we had the first in-person meeting in Kigali, Rwanda at ICLEAR, International Conference on Learning Representations. And next year we are planning for another in-person workshop in Austria, Vienna, which we're going to have another African NLP workshop at ICLEAR. And we want to encourage as many people here to also try to submit some of your works. I'm trying to see if we can encourage some of the winners of this competition to also submit their work to the African NLP workshop for next year. All right, thank you. You can join us on Slack using this link. So that's the short introduction about Masakhane. Right.
Thanks, David. I see that we have Basil and Julius here, who are both novices in the NLP field. Julius, I've seen your work before. I don't know if I'd classify you as a novice anymore. I think you've leveled up to intermediate. But I highly recommend joining this Masakhane Slack group. It's a great way to be in touch with novices as well as pros, such as David. Basil, it's so interesting to see that you've been following David's work, and now that you get to hear him speak, and hopefully you get to connect after this.
Right.
David, do you want to share a bit about why the data was collected, how it was collected, and why it's important to have parts of speech classification models.
Sure. So I prepared a few slides. I hope it covers everything. This is based on our recent paper at ACL in 2023 on Masakhane part of speech tagging for typologically diverse African languages. So prior to this project, we only have very few languages with part of speech data sets on the web that are discoverable. I mean, people have been creating this, but not everyone open source this kind of data sets. The most popular platform where people do this is on the Universal Dependency platform. And I think we only have like 2 languages with training data on part of speech for African languages. One is Nigerian Pidgin, because we have a team of researchers from France that came to the University of Ibadan for like 2 years to work on this. And we had one on Wolof. They did this during this master's program, I think in Belgium or in France with one UD expert. So the task of part of speech is just a very simple task of assigning a grammatical category or a tag to each word. So this is an example of the dog chased the cat from the room. From basic primary school or high school knowledge, we know that there is the terminal. The dog is noun, chase is a verb, and from is adposition, and cats and room are also nouns. So the question is, how can we do this across many languages? Because this is fundamental task that is important in many applications, from machine translation to parsing, text chunking. I've seen people use this to improve speech recognition systems and synthesis, and it's also quite useful for building tokenizers for African languages. One of the most widely popular tokenizer, the Stanza, by the Stanford NLP group, actually uses data from the UD. And this is based on the tokenization they find from the UD. So, but until this project, we don't have really large-scale POS data set for African languages. The one we have that is really indigenous was Wolof. So we collaborated with one of the creators of this, of the Wolof part of speech tag in the UD to do this project. We have languages from different language groups. Many of them are from the Niger-Congo family. We cover mostly West African languages, Sub-Saharan African languages, and East Africa and southern African languages. So our corpus is based on the news domain. The data was created by first asking annotators to annotate the first 100 examples. And after that, we did a training to build an automatic tagger based on these 100 examples to label the rest. And then we asked annotators to fix the corrections. The reason why we had to do that, because it's a very time-consuming task. People have to label every single word with the appropriate tags. So in a way to speed up that, we use this idea for machine learning called active learning to speed up the process. So in this task, our focus is, what if we are given like training data in 18 out of these 20 languages we have created? Can you build a part of speech tagger for the unseen languages that are not covered by our corpus? One thing you have to know, that part of speech is language dependent, and you can achieve a very high accuracy on this task, as high as like 90% on if you have training data. But if you don't have training data, the performance can go as low as like 50%. So, and the reason why this is an important problem is because it's just impossible to create benchmark POS data set for over 2,000 African languages. And how do we address this? So there's a need to develop very effective method for cross-lingual transfer. How do you transfer from existing data sets with training examples to a new language? So we designed a task, which is given POS data sets in 18 languages, can you adapt it to these 2 languages? We chose 2, one Luo, which is a Kenyan language, and the only language from the Nilo-Saharan group, language family group, in the Masakhane post dataset. And the second language is Setswana, a Botswana or South African language from the Southern Bantu language family. And the interesting thing with these 2 languages is that they are not related in any way to, they are mostly not related to the entire data sets, the remaining 18 languages. Luo is distinct, is the only language from the Nilo-Saharan group. And Setswana is also distinct, even though we do cover a lot of languages from South Africa. It's very different from isiZulu. Even from the writing, you will see that it's very different. It's very different from isiXhosa, it's different from Shishona, and has its own unique properties like multi-token words. That means you can have a single word broken down into 2 tokens, but it's still referring to the same word. And then they will be assigned the same part of speech. So it's kind of very unique selection of languages. I can go on and on because we studied this a lot. But I will just stop there and listen to some of the solutions to this task. Thank you.
Thank you, David. I understand it's really easy to go on and on about something that you're really passionate about. However, I would like to pass it on to Alex, our first place winner, Random Seed 19. He's introduced himself a little bit, but over to you to share about your solutions. I just want to mention we will be having a Q&A session at the end of the winners presenting their solutions. So if you want to jot down your questions on a piece of paper or put them into the chat, please do, and then we will ask the winners about them later. Over to you, Alex.
Hello, everyone. I'm Alexander, and today I'll be sharing my approach for this challenge. So as David already told, the task at hand involves part of speech tagging, essentially a token classification task. The goal is to assign one of 17 part of speech tags to each word or token in a given sentence, with the training data available in 18 languages and test predictions required for Luo and Setswana. And accuracy is a metric for this competition. So about the model architecture I employed, I based my solution on the NLLB 200, means no language left behind model. It's an open source multi-language translation model developed by Meta, and it is specifically designed for translating among 200 languages and including low resource one. It comes in various sizes. This model is a sequence-to-sequence encoder-decoder model, and for this competition, I utilized only the encoder part of the NLLB 200 as the base pre-trained model. And the linear layer was added atop for performing part of speech token classification task. So the whole architecture is quite simple using the base pre-trained model. Now, regarding fine-tuning techniques, I opted for the smallest model with 600 million parameters. I tried also larger models, but they yielded slightly inferior results, likely due to increased overfitting for trained languages. I also used the LoRa, low rank adaptation approach for fine-tuning a more efficient alternative to full fine-tuning. This method reduced trainable parameters, number of trainable parameters, training time, and accommodated limited GPU resources, while delivering results comparable to full fine-tuning of the model. And the final training process was done in 2 stages. Firstly, training on data from selected training languages and predicting part-of-speech tags for Luo and Setswana. And subsequently, I used these predicted tags as pseudo-labels as an additional training data and trained model once again from the scratch. And the entire final pipeline, consisting of 10 epochs for each stage, took approximately 30 minutes on T4 GPU using free Google Cloud. Some words about the selection of trained languages. Initially, I trained the model on all available languages and achieving a public score of about 0.7. And subsequently, I trained models for each individual language, so only one language, and recording public scores for each, because there also was a validation score, but it was very, very high because it has the labeled data. And for unseen languages, I could only base my score on the public score. I then selected the best performance in the language, namely Luganda, and combined it with others, and so on. Not every possible combination was explored, but the focus was on those from the top languages, and I tried up to a set of 5 languages. And as a result, I stopped at a set of 4 languages for training data. Luganda, Igbo, Mosi, and Shoshona. And I also tried 5 language combinations, but they gave slightly worse results. And the model trained with pseudo-labels stood out and yielding the best result with an accuracy of 0.742 on both public and private datasets. So if you're interested, the code is available on GitHub. So that's all, I think, and thank you very much for your attention and for great competition.
Alex, thank you so much. What a perfect summary of your solution. David was thoroughly impressed with your solution when we were talking about it. So I see the hand clap there. Next, I'd like to hand over to Iheb, second place winner. Iheb, would you like to introduce yourself and share your screen? Over to you.
Yeah, sure. So, hello everyone. My name is Iheb Shaban. I'm a final year engineering student in École Polytechnique de Tunisie, and I also work as a data scientist on a part-time basis. So I will be sharing my second place solution for the Lacuna challenge. Ami, can you please give me access to share my screen?
Yes, of course. Give me 30 seconds. Could you try now, please?
Okay. Great. I think you can see now my screen.
Correct.
Yes.
Yes.
Okay. So as I said, I will be presenting my second place solution. I'm known on the platform as Reacher. So the agenda is I already introduced myself, and then I will be sharing my approach. So as I said, I'm a final year engineering student working as a data scientist. Other information about my background, I'm an ICPC 23 world regionalist, and I'm also a Kaggle competitions expert with the top ranks in more than 6 competitions. And I also practice on Zindi. So this is the pipeline of my solution. First, I filtered the training languages. This is based on the paper, the Lacuna Pose paper. I mainly used Bantu languages plus CCM, Wolof, and VVG. This was experimental, based on cross-validation and also public score. Then I perform 4 rounds of pseudo tagging. I first train a model, then I infer on the unlabeled monolingual corpus shared by David. I generate pseudo labels. Then I sample randomly 50% of these sentences, and then retrain the model for 4 rounds. And finally, I applied post-processing on prediction that I will be explaining. So for validation, I always leave two languages, two unseen languages for validation. This is to mimic test set, as we for the leaderboard we predict for two unseen languages, which are Setswana and Luo. For the model, I used the pre-trained Afro XLM Roberta Large and employed custom residual LSTM head on top of token logits to capture relationship between tokens. For the training, as I'm using pseudo labels, which are more likely noisy, I add label smoothing. I also clip gradients for more stable training, and finally, I train with mixed precision. Besides, I employed several data augmentation. This is crucial in my pipeline to push the model to learn multilingual features. An example of data augmentation used is cat mix. Let's say in a batch we have two sentences. The one is a Ho language, and the second one is BAM language. We first randomly chose a starting position in the, let's say, second sentence. We have predefined cut length. We cut the tokens and the associated labels, and we paste them in the second sentence, creating a new sentence having both languages. Also, I randomly mask tokens. This works as a regularization technique. Finally, I employed post-processing by Neldermead simplex algorithm to find the optimal threshold for each class. Also, a token level post-process, which is assigning the same prediction for each word based on the histograms. And that's it. This is my solution.
Amazing. Thank you so much, Ihab. One of the things that has interested me with this parts of speech classification competition is I think I might hold some trauma around past NLP applications where the running and the iteration and experimentation of NLP is normally very long, and the training can take up to days. But it was really nice to see the parts of speech solutions being quite succinct models. So well done to the winners, and thank you for helping breaking that trauma that NLP doesn't have to be massive. Our third place winner is actually a team Overfit Gambit. What? Yes, Team Overfit Gambit. There are a team of two. Unfortunately, the one teammate is not here, but thankfully we have Ahmed, who has introduced himself already, but I'd like to hand it over to you to share your solution.
Yeah, thank you. So let me know when you can see the entire screen.
Yes, we can see your screen.
Okay, so I'll be presenting our third place solution, the challenge, and this is presented by myself and my teammate Imanshu Nayal, but unfortunately he's not able to join us today. So we'll see a bit of the table of contents for this presentation. First of all, I'll introduce briefly our team. Then we will have a global overview of the solution. Then I will explain how we did the Muscat language model training. And then I will explain how we did the final step, which is the part of speech tagging. And finally, I will conclude with a conclusion and some perspectives about this topic, and also based on what the winners have shared. So let's jump to the team introduction. So our team name is Overfit Gambit Accepted. And yeah, it's a bit funny because this is referring to an opening in the chess game. And it means that it's kind of a gambling accepted. So we name it that because in this challenge, the validation was tricky, and the test languages are not included in the train. So in order to build the validation strategy is really difficult, and it's kind of a gambling game. So yeah, I will introduce myself, Ahmed Atiya. I have 25 years. I'm born in Tunisia. I have studied there software engineering at the National Institute of Applied Sciences and Technologies. And now I'm based in Germany, and I work as a data scientist at Vodafone. So my teammate is Imanshu Nail. He has 21 years, born in India, and he studied computer science from the graphic era at the Hill University. So now let's jump to the solution overview. And before explaining the final solution, I will just give a bit of background how we reach it to that. So at the beginning, we have tried the open source large language model shared by David. Thanks, David, for sharing that. So it includes 75 languages, and a lot of the train languages and one of the test languages is included in that model. So at the beginning, we have just fine-tuned this model on the downstream task, which is the part of speech tagging. And yeah, we got pretty good results, but then we said, okay, what if we fine-tune a bit this already pre-trained large language model on some of the languages that are more interesting in our case. And those languages are, of course, the test languages, because those are unseen in the train data of the part of speech tagging. But after, based on some experiment, we have added the WAL and the PCM language, as they have gave a boost into the entire final score, the final score. So yeah, we have constructed a corpus data based on the GitHub repository of Masakhane, and we have to fine-tune a bit this already pre-trained large language model, and then we've got our base model. So at this stage, we have included all the full train data of the part of speech tagging, and we have trained it on the token classification. And we've got the first model. Then we did also rounds of pseudo labeling. So basically, we used this model to predict the Luo and Setswana part of speech tags. And then we have added them to the training data, and we did that 3 times until hitting the final solution. So this is the solution overview. Now, let's see how we did the Muscat language model training. So as I said, it's not a training from scratch. It's just a fine-tuning of already pre-trained model. And the base model is the Afro XLMR large trained on 75 language. Our train corpus was 4 languages, and we constructed that based on the corpuses on the Masakhane GitHub repository. So we trained it for 5 epochs. We used a batch size of 8 and a Muscat language modeling probability of 0.25. So for the resources, we just used the free Kaggle T4 as a GPU. Now let's see how we did the part of speech tagging. So as I said, we used the base model is the output of the output after fine-tuning on the 4 languages. We used all the languages given by the train CSV file in the Zindi. We trained it just for 2 epochs as it was overfitting. And as I said, the validation in this channel is a bit tricky. So at the end, we have based the choice of the model on the public scope. So it's not good to trust the public score, but in this competition, we did not have much solutions or much choices. So I'll give a bit how results were improved after pseudo labeling. So as you can see, between the initial trained model and the final one after the 3rd round, there is a really a difference, and this is big when you see the leaderboard results. So now we'll hit some conclusions and perspectives. So the first conclusion is that the masked language models really help it in our solution. So because the pre-trained model was knowing about the 75 languages, but the more you add languages, the more it will be not much confident about all these languages. So doing a fine-tuning on the interesting languages could help to focus more on them. Also, the pseudo-labeling gives a little boost, and I think this is confirmed as all the winner solution has used it in their solution. So some perspective. So I've seen already shared by Ihab the data augmentation techniques, and then think it's really interesting because the data is small. So this could be very helpful. Also, if we had a larger corpus of the test data, this could help in the next phase, which is the part of speech tagging. And also the pseudo labeling could be much helpful if we had more or larger unlabeled data. So yeah, that's it. Thank you everyone for your attention, and looking for your questions.
Thank you so much, Ahmed. I think your point about the want and I think it's such an African NLP want to always have more data. And I wonder if we'll ever get there. But thankfully with Lacuna, we are making strides in that direction. And I think the winner solutions show that you can beat the academics' accuracy from their paper with hard work and with a small data set. So yeah, very interested to see what comes next. I'm now going to open the floor for questions. Please feel free to raise your hand and unmute yourself. You can direct questions to the winners, asking specific questions about their solutions. You can direct questions to Jennifer about the Lacuna Fund, to David about data collection and why he thought it was important to host a competition like this. Yeah, I'm going to open up the floor. So raise your hand if you'd like to question or make a comment. Hi, Nuruddin, do you want to unmute yourself and ask your question or make your comment?
Okay, hello. My name is Nuruddin, and I'm joining this call from Nigeria. So my question from the presentation, I can see that they made use of pseudo labeling to make increase the size of the data set. So my question is, does it have any significant impact on the accuracy of the model? That is, maybe did you train the model with data set that was pseudo labeling wasn't used, and maybe another portion of the data set with pseudo labeling, and does it have maybe any significant impact when it comes to the accuracy of the model? Thank you.
Nuruddin, am I correct in assuming that that question is directed at Ahmed, or who was it directed at?
No, it was directed at Ahmad. Sorry.
Yeah, sorry, I was muted. I did not get the question, so could you repeat it, please? Maybe it's the fault of the voice.
Okay, so I think what I'm trying to say is, does pseudo labeling has any significant impact on the accuracy of the model at the end of the day?
Yeah, so as I've shared in one of the latest slides, so it improves the accuracy of the entire model. The improvement is not really a huge one, but yeah, in terms of competition, it could give you a boost. But the idea is, if like the model has not seen the test languages, so if you add that, it would be very, very valuable for the model. So you could expand this idea for more unseen data, not only to the test data as we did in our competition. So let's say if we have a news corpus of those two languages, we can just add them and we don't need to label them. And then it could be helpful for our models. I think that I have understood your question.
Yes, thank you.
Yeah.
Amazing, good
Okay.
answer, Ahmed. Temi, do you want to let us know where you're calling in from and what your question or comment is?
Hi, I'm speaking from South Africa. My question will be directed to Dave, and before that, I would like to thank him for his presentation, and have been reading his paper for some days now, and I've also been following his work in Masakhane. I want to ask how the data was collected. Were they in different languages, or was it in English and then translated to the other languages?
All right, thank you very much. It's a great question. We did not translate, so we collected data sets from African languages. Oh, but wait a minute, we did translate, but so the project was divided into 3 parts. So we wanted to use the news domain, but for some African languages like Wolof or Gomala in Cameroon, we do not really have a lot of news domain data. So we translated the French sentences in Wolof and Gomala to, French sentences to Gomala and Wolof, but the annotation was done on the translated text. So we are not translating a data with POS tags and then transferring it to an African language. We only translated the monolingual text. So that's one thing that you should note. So the tags that you will get in French are not the same as what you will get in that African language. The only reason why we have to translate the source text is just because it's not available. And we don't want to use the Bible as our base text for this language. And the annotation was done completely independently after the translation phase. I hope that answered the question. Yeah.
Thank you, Mr. David.
Right,
Great, thank you so much for the question, Pemi. Does anyone else have any questions or comments? Please do feel free to raise your hand. I have a question for everyone. It's quite a broad question. What's next? And what's next in terms of what data do we need to collect next? What are we going to do with these models? Do these models, are they just an interesting learning curve? Is there a publication? Is there an application? And what would that application look like? I'd like to hear the winners' thoughts on if they've thought about this. I'd like to hear the audience. What would your dream outcome be? And then I'd love to hear, David, what your dream outcome would be. So do one of the winners want to start first? just to clarify, you can answer any one of the questions with the general what's next. How do you take these models from a cool model on GitHub to what's next?
Okay, we speak. I think we can make use of these models to label some other unlabeled corpus, and I think this will help us in other tasks. As David mentioned, part of speech tagging is an essential steps in other applications like speech recognition and so on.
Such a good point. David, how you mentioned, or how did you collect the data, and is there any quick digital data that one could collect and apply these models to increase corpus size?
Yeah, that's a great question. So the way we did the annotation, I told you, is in two phases, because we had to label each word, and thinking about it is really time consuming. So we asked annotators to label, I think, the first 100 or 200 sentences. And based on this annotation, we train a tagger to automatically label the rest. And then we now ask the annotators to fix the mistakes of the tagger. And we use 3 annotators, so it's not just, we don't have a situation where one annotator is just accepting everything of the tag. So we also have some automatic checks. And even though the tagger did pretty good at some tags like punctuations, most of the time it will get punctuations correctly, like proper nouns because of the capitalization. The capitalization doesn't really help for languages like Shishona is Zulu, because you have capitalization in between words, because of the what do you call the prefix before proper nouns in these languages. So this is the way we collected the data, and after a lot of checks and several months, actually this took us more than a year to collect, we're able to come up with a very good quality corpus. One possible extension of this would be to order universal dependency passing task. So that we are working on one now with the Masakhane. So currently we're thinking of extending this to like 10 or 11 African languages. Of course, if we have more funding, we can maybe extend to more languages, but for now it's to 11 African languages that we're trying to extend this corpus to. So for the application areas, one of my intention is to see if we can have like a very good tokenization for African languages. Tokenization is a big problem. I mean, if you try to build models, the models breaks if it cannot tokenize. So I'm very happy that I think someone talked about Amazigh language in North Africa. They use a different script. So even our model cannot tokenize this. Even though it covers 75 languages, we cannot tokenize this language because we needed some examples to tell us how to tokenize this language. So there are a lot of tricks that can be done, and part of speech tagging can give us an idea on how to do tokenization very well for languages of different scripts that are different from Latin. So those are possible extensions that I can see. And yeah, of course, I'll be happy to hear about it. Yeah.
I'm going to put one of the so-claimed novices on the spot. I think you are not doing justice to yourself. I know, Julius, you are definitely an intermediate by now. But Julius and Basil, being thrown in the deep end here, what do you think would be next? And what have you learned about the importance of parts of speech?
Thank you, Ami. and congratulations to the winners of the competition. I joined the competition, but I was ranked very badly. It was my first dealing with NLP. And I've got some insights today. And I had a question, Ami. Are these solutions open sourced? Like, could we learn more from Sim?
Yes, definitely. I do not know if I have done it yet, but I will do it tomorrow. I will share the GitHub repo with the solutions on the discussion board, so you can go and view them.
Oh, okay. Yeah, so I think I don't have much today. So thank you so much for the chance to
Well,
say something.
once I've shared the solutions on the discussion board, I'd love any comments or to start a discussion with the winners of, why did you do that? That's confusing. Or that was a cool way of coding. I think that would be a great way to learn and to share.
Thank you.
Thank you so much, Julius. Does anyone else have any last comments or questions before we wrap up today? Oh, from Basil. Sorry, he can't talk, but he's learned a lot from the presentations, especially steps one could take in providing solutions in POS languages. They look really cool, which I totally agree. Jennifer, as someone who is passionate about creating and supporting the creation of data sets, what are your thoughts? Where's next for you?
Well, I am really excited to hear about some of the ideas for how these models and solutions can help advance African NLP, and how there could be extensions and perhaps increase the size of the corpus and improve the performance of the models. And I'd love to, I look farther ahead, and I'd love to someday see some of these models be used in applications that can help with machine translation and speech recognition and some of the things that others have mentioned. So I hope that's in the future. And I'm really excited to also share with folks that thanks to another contribution from google.org, Lacuna Fund is planning to issue another RFP in 2024 for NLP data sets. So be on the lookout for that if that's something that you're interested in.
That's amazing. Yeah, I highly recommend working with the Lacuna Fund. This is our second opportunity we've had to work with them, and it's such a privilege joining part of their community, linking up with other people who are passionate about underrepresented communities. So highly recommend it.
And
that's
thank you, Amy. I want to just say thank you so much. It's been a great experience partnering with Zindi and Masakhane and David on this challenge. So we really appreciate the opportunity.
Thank you, Jennifer. Our time's up today. This recording will be put onto YouTube sometime next week and posted on the competition page, so you'll be able to find it there. Thank you so much for joining us. It's been a privilege. Cheers, everyone.
Thank you. Bye.
Thank you very much.
Thank you. Goodbye.